Today is May the 19th, 2019, and what I want to go over tonight is some questions and discussions that started on a video I posted recently on the Williamson amplifier, and it was about headroom and bias on the final amplifier. That's the specific subject, and I've done some research, and there's been some back and forth communication with you guys, and I tried to get a handle on exactly what I'm trying to measure, and I think I have something here to show you. Now, first of all, as I understand it, headroom, technically, from like a mixing point of view, is a full level signal is 0 dB. Whatever its reference is, 0 dB M or 0 dB units, whatever the reference is, doesn't matter. And since I'm not a musician and an artist, I just have to look at it from a purely technical point of view. But if you drive it up to 0, which I think is pretty much the idea, and that is in recordings, and that is to increase the signal to noise ratio as best you can. Well, even at 0 dB right here, you've still got 3 dB right here, which is twice the power if you're measuring power. If you've got 10 watts right here, you've got 20 watts right here. Of course, I know that in recording, in the voltage amplifier parts, we're not dealing with that kind of power. We're dealing with voltage levels, but I don't mean to get off on a tangent here. But anyway, if you drive it up to 0, then everything is perfect, and you've got the headroom. The headroom is what they call it. If you look it up and you do some research on the internet, Wikipedia talks about this and whatever, the headroom is between 0 and 3. And while the distortion is going to be increasing here, it's probably going to be pretty insignificant. And it gives you that room between where you're actually trying to keep your average level at, and even if it's bouncing over here in the red, it's going to sound good. It's going to sound just fine. The amount of distortion increase is going to be insignificant. Now, past 3, it's going to be clipping. And it's going to start sounding really bad. So that's what I understand about headroom from that perspective. But that's not the type of perspective we're talking about here. What we're talking about here, and I'm going to be using this Dynaco amplifier. That's been my standby for so many years. Really, really nice amp. What I understand we're talking about here is headroom between the bias levels. Now, the normal bias level on this amplifier right here sets the cathode current on each tube at 70 milliamps. 70 milliamps per tube for 2 tubes, which would be 140 milliamps. Well, I'm going to run it down to 60 milliamps per tube, and we're going to measure the exact voltage it takes to drive it, the exact power output, and the THD. And then we'll run it up to 80 milliamps. So if this is normal, we're going to call this normal. We would call this cold, and we'd call this hot. Now, one of the ways that I know that musicians oftentimes set their bias level is they set it at some percentage of the voltage times the plate voltage times the cathode current, and relate that to the maximum plate dissipation listed in the tube manuals. Well, that makes sense too. And some people want to run it at 50, some say 60, some say 70. Well, it happens to be a fact, and you're going to actually see it here, that the hotter you run the tube, the more power you get out and the less distortion you get. But there's going to be a point there where you're going to be running it so hot that the life of the tube may not be very long. I don't know if it's going to be a week or 2 weeks or a month or a year. But as you run it colder, it's going to last longer because it's not as hot. But it isn't not going to perform as well down here. It's going to perform technically better up here, even than it does here. It's going to perform better hot, but that better may not be the way the musician wants the overdrive, the crunch, the fuzz, or whatever words are used to describe the characteristics of the music. But from a purely technical point of view, the hotter you run it, the better it works until you melt it down. So let's make some measurements at 60 and 80. I don't want to make it too long. We don't even need to make any right here. This is normal. We want to run it cold and hot and see if we can see any difference. I have done this, and I'm not going to tell you what it is yet, but let's do it and see how it turns out. Let me get it hooked up here and we'll see. Okay. The first setup here is going to be at 0.6, and you can watch the voltage over here. I've got them set as close as I can. There's one tube, say 0.60. As you can read that, it's really important that you do. Yeah, that's 61.2 milliamps. This is 60.23. It's hard to make them exactly the same. I do have a balance control I put into this one. I think you can see it here in the movie. I'm moving it right there, and I can go between. It's a really good idea. And I also have an AC balance in here. This is an original 6A-N8 Dynaco board design. It's actually a new board that I get from my Triode Electronics. I think is where they come from. They make another one called a Poseidon board. Make another one for this. It has a 12AU and a 12AX7, 12AX and a U. Anyway, that was 60 milliamps. And this one is, we do the best we can here. That was 61. I can maybe touch up the balance here just a teeny weeny bit and lower that one, or I may raise it. I don't know which way I'm going to go. Oh, okay. See, that one went down ever so slightly. I mean, you can sit here and split hairs with this thing. Okay, that's close enough. That's 60 per. Now, we're going to run it at 50 watts. Okay? So we'll turn this guy around here to our watt meter. I believe you can see all that without me getting too weird. This is power. So I'm going to drive it and crank up the power here. There's 30 watts. 60. I don't want to put it too high. We'll set it as close to 50 as we can. 21. Some wide ranges here. 50 watts. Okay, nice sine wave there. This is a, well, that's at 41 hertz, sorry. We need to go up to maybe a kilohertz. Let's do it at a kilohertz. Okay, gotta watch me fumble just a little bit, but you see the power stays the same, so it actually does quite well. I don't know if I'm going to make it exactly 50, but we'll try to go a hair higher. 51. Okay. Now, if you can see the THD, let me zoom back out and try to keep my. Here's THD up here, 0.48. 51 watts. We're going to write all this down so we can compare it, because it's going to be really close. Okay, we got 51.08 watts. We got 0.488% THD. And, oh darn, you know what? I'm not measuring the input voltage. Okay, this is okay. Let me just stop, hook up the input voltage, and we'll just add that to it. Okay, we're back, and we don't need to add much to that because we still see. I'm confident that we're still able to see all the right numbers. There's the same power, 51 point. It's going to vary a little bit. I'm monitoring the input voltage at exactly 120. Went to 119. Let's make that 20. 120. Got to keep everything the same. There's our kilohertz. We'll run that, even that up a little bit. Make sure we got a full 1,000. 50.6 watts, 0.526, and our driving voltage, which is the important thing here, this number right here, 1.5994. Well, we got that one down. Okay, I'm going to mark those out and write this again. 50.58. The drive voltage is 1.5994, 1 kilohertz, and a THD is 0.524%. Okay, that's cold. Now I'll stop the camera so you won't see me fumble too much, and then I'm gonna run the bias level more positive, less negative. So we're running at 80 milliamps, and we'll make exactly the same measurements and see the difference. Okay, now I've got the bias set at 80 milliamps per tube. Let's go over here and take a look at that so that you can see that. And they're both actually very nicely balanced. 80.5 milliamps, and this other one is 80.2. You know, really good. Okay, let's take that. Well, those tubes are hot. Okay, now what we're going to do is see the same thing, or see what happens. It's different. Get it on the same thing, so we're looking at the same numbers here, I hope. Excuse me for going. Okay, now nothing else has changed. I'm going to plug it right back in, and we want to be able to get back to that power level. Okay, well, our power dropped a good bit. No, I'm sorry. It rose slightly. Yeah, that's what I was expecting. I have tried this before. Oh, darn it. I hate it when you get loose connections and have to start fighting the equipment. There we go. Okay, so what we ended up doing was making the bias less. So now we have 52.01 watts. The driving voltage is still 1.5989, 1.5989. So I'm going to change by millivolts, so it's 1 kilohertz. And our THD is gone to 0.376%. So we ran it hotter, we get more power, about 2 watts more. We get about 2 more watts at lower distortion by running it hot. And, well, you know what? This one is coming out so close that it's absolutely insignificant. Here, I've got to turn the light on and I'll show you what the data is that's written down here. Here's the numbers I was trying to compare. Okay, this is cold up here. This is hot down here. I've made these measurements a time or two before, and I saw a very slight difference. A very slight difference down here. See, this is 1.599. This is 1.598. That's the same number. So in this case, there was really no difference in the driving voltage, except I got more power out down here. What I found out the other day when I posted this as a comment is there was something like 24 millivolts difference between these numbers. It took like 24 millivolts more up here to drive it than it did down here, because the bias is higher and it takes more voltage to overcome that bias. But it was so insignificant that, you know, to play a guitar, hit it a little bit harder to get that much more, just almost an insignificant amount of voltage in millivolts difference, is it doesn't make any difference, is what I'm trying to tell you, for all real purposes. Sorry, but technically it doesn't. And I think these measurements are actually quite valid and accurate. Now, from a creative point of view and from other amplifiers, I have to say, you know, maybe if it's a Marshall amp or who knows, whatever brand your choice is, and whatever level of distortion you want to run it at. Okay, well, I'll tell you what we can do. Let's run it a little hotter. Let's run it up to 5%. I think I did see a difference there. Yeah, let's do that. Let's do that. Okay, this is going to be, yeah, we got to go a little bit further. Okay, Well, we got it set here. Let's just keep running it up until we get at a really loud playing level. Most amplifiers only put out their rated power at about 10% THD. Let's run it up to 10%. That's 11%. Okay, at 10%, okay, this is hot. Now we're getting, got to go to another page and we'll have to analyze this data again. But I think this is worth doing. It's fun. Okay, at 10%, we got 61.9 watts, and it's taking 2.013 volts to drive it. Okay, now I'm going to go back to 60, and we'll see. It's going to actually have to take a little bit more of this to get to these 2 points. Okay, so let's go there and see what happens. Okay, I've got the current back down to 60 milliamps per tube. So let's go back over here and do this again. Now up here I've actually changed nothing. So let's just plug it back in. Let's see what happens. I can hear it. Okay. We're still 10% distortion. We haven't changed this. 2.013, that's exactly. And it's putting out 61.74 watts. 61.74 watts. Wow. Nothing changed again. 2. Okay. Here's what that data looks like. We're running cold now. This was hot and cold. We're running it all the way up to 10% THD. I'll show you the clipping here in a minute. We were getting at 61.9 watts hot with this much drive voltage. Now we're getting at 61.74 watts cold with exactly the same drive voltage. I mean, it dropped, you know, 0.2 watts, even less than 0.2. And, you know, we're going to be clipping fairly heavy now. There's what it looks like. So my conclusion tonight, which is just ever so slightly different from what it was the other night, like I say, it was like 24 millivolts difference. Tonight I don't even measure 24 millivolts difference. It doesn't look like you get one iota of anything different in as far as headroom goes, so to speak. Headroom being the ability to drive it a little bit harder to get a little bit more power out of it by changing the bias. What it does do is a lower negative number, like say lower, like if the bias, let's suppose it's 40 volts, negative 40 volts. If you lower it to say negative 37, it's going to run hotter. You're going to get more power. You're going to get less distortion. If you run it, say, down from, say, negative 37 to negative 34, I'm dropping it like 3 volts at a time, it's going to get hotter. It's going to put out a little bit more power. The distortion's actually going to drop a little bit more. I mean, we've got it up at 10% THD now, so we're clipping. And once we get into that level of driving it, not much is going to change. So there you go, ladies and gentlemen. That's my measurement, and that's my that's the conclusion I've come to twice. This time even closer than it was the other day. That changing the bias level on your output tubes is not going to give you more headroom. Nothing more or less.